Let's move on to one of the tougher topics in the test, which is quadratics. Now, when we were dealing with linear functions back in the algebra section, there was one equation that kept coming up over and over and over and over again. Remember what it was? Y equals mx plus b. And hopefully at this point, you've seen it so many times that it is just etched in your memory and you're familiar with what all the terms mean. If you're still a little rusty on this, feel free to go back and review that lesson, right? The lessons on linear functions. But the reason I bring this up is because as we move into quadratics here, in a similar way, there is an equation that is sort of like the default quadratic function that we use. And that is quadratic form. Ax squared plus bx plus c. We want to get really, really good at recognizing this wherever it comes up, right? So, for example, if I have an expression, something like y equals 4x squared minus 7x plus 2, I need to immediately be able to look at that and say, oh, this is in quadratic form because the a is 4, the b is -7, and the c is 2, right? It matches this. Or even something like this, 7x squared plus 3. I'm going to leave a little space here. 7x squared plus 3. Because technically, this is 7x squared plus 0x plus 3. So being able to recognize that we're dealing with a quadratic is really, really critical for the questions that we're going to do. All right, now one building block that's very important here is foiling, right? Being able to distribute factored terms, and I'll show you what that looks like. Let's say that I have an expression like this, x plus 2 times x plus 3, right? Foiling is just an acronym, or FOIL is just an acronym that allows me to expand this or distribute it. And what it stands for, if you're not familiar with it, first, outer, inner, last. First, outer, inner, last. And this just tells me the way that I multiply it through. So I'll take the first terms, x and x, multiply those together. That gives me x squared. Take the outer terms, the x and the 3, multiply those together. That gives me 3x. The inner terms, 2 and x, that's 2x. And the last terms, 2 and 3, which is 6. All right, so like terms allows me to combine the 3x and 2x. What do I end up with? X squared plus 5x plus 6. So pause there just for a second. I hope you recognize that we are in the quadratic form right now, right? So foiling this expression gets us into the quadratic form. And that's the connection between FOIL and quadratics. Here comes the interesting part. How do we go the other way? That is, how do we get from this expression here back to this? And that's called factoring, right? Repackaging it, putting Humpty Dumpty back together again. All right, well, there is a method to do this. There's a method to the madness. And here's how it works. You're going to look at the last term, right? You're going to look at the last term in this quadratic expression and say, all right, x squared plus 5x plus 6. 6 is the last term. Then you think, what are some numbers that multiply to 6? What are two numbers that when you multiply them together create 6? Well, I'll write them out. And I'll write them out down here. 1 and 6, 2 and 3, 3 and 2, but that's the same thing, and 6 and 1, so that's it, right? 1 and 6 and 2 and 3. Then you look at the middle term and say, okay, of the numbers that I have here, 1, 6 and 2, 3, which ones of these add up to 5? Well, 2 and 3 do. So that tells me that when I repackage it, it's going to look like this. X plus 2 times x plus 3, right? Okay, now I'm just going to add one little step. And for this, I will go over here. Let's use a different expression this time. Let's say that we have x squared. I'll make it interesting. X squared minus 3x minus 10 equals 0, right? So this is now an equation. Everyone follow this? This is now an equation because it's set equal to something. And what I'm looking to do here is solve this equation. Find the value or values of x that make this equation true. And the way I'm going to do this is as follows. I'm going to start by factoring. So let me do my trick. I'm looking for two numbers that multiply to negative 10, right? And let's think of the numbers that multiply to negative 10. There are more this time. Well, there's 1 and negative 10. There's 2 and negative 5. There's 5 and negative 2. And there's negative 1 and 10. I'm keeping all the negatives on that side, right? 1 and negative 10, 10 and negative 1, 2 and negative 5, 5 and negative 2. Which set here adds up to negative 3? Well, 10 and negative 1 makes positive 9, so that's not right. 1 and negative 10 makes negative 9, that's not right. 2 and negative 5, that works, right? 2 plus negative 5 is negative 3, and 5 and negative 2, that doesn't work. So the terms that I'm looking for are x plus 2 times x minus 5 equals 0. Now here's the last step to solving by factoring. Take a look at this, right? This is a multiplication. I'm basically saying this value right here times this value right here is equal to 0. Well, what does that mean? If a times b equals 0, what must be true? Well, either a must be 0 or b must be 0, right? If Bob times Joe equals 0, either Bob must be 0 or Joe must be 0 for me to get 0. So what I'm going to do is consider both possibilities. I'm going to say, okay, well, either this term right here could be 0, x plus 2 could equal 0, or x minus 5 could equal 0. And if x plus 2 equals 0, then x equals negative 2. And if x minus 5 equals 0, then x equals positive 5. So the two solutions to this quadratic expression, this quadratic equation that I have right here, are negative 2 and positive 5. Okay, I realize this is a little bit clunky, and it takes a little bit of practice to get used to. But it's an important skill to have, being able to go in both directions, being able to go from this, right, x plus 2 times x plus 3 to this, to the expanded form, and backwards again. Now, unfortunately, sometimes there's no happily ever after, right? As in, sometimes, and I'll use this expression right here that I had, you're going to get numbers that don't factor nice and evenly, or the first term is not 1, right? And in that case, we're going to use something that I call the nuclear option. That is the quadratic equation. Now, the quadratic equation will solve any quadratic, right? It takes care of everything. But I'll say that this way is oftentimes a little nicer. And then, of course, you can also use your calculator, which we'll get into a little more on the next few questions. But I want you to have the quadratic equation. Again, the nuclear option that just takes care of everything. And here it is. To solve any quadratic function, you can plug it in, you can plug the constants in here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, what are all these a, b's, and c's? I'm so glad you asked. They're the terms that came from this generic version. So again, let's say that we have this expression right here. Y equals 4x squared minus 7x plus 2. In this case, the a is 4, the b is negative 7, and the c is 2. Let's plug it into what we have, right? Negative b. Okay, so negative b would be negative 7. So positive 7 plus or minus the square root of negative 7 squared, so that's 49, minus 4 times a, which is in this case is 4, right? A is 4, times c, which is 2, all divided by 2 times our a, which is 4. Now, as you can see, this isn't going to come out to something very pretty. I'll simplify it a little bit more. It's 7 plus or minus the square root of, what's that? 49 minus 16 times 2 is 32, so 17, the square root of 17. X equals 7 plus or minus the square root of 17 over 8. And again, here I'm going to get two expressions, right? I'm going to get two solutions, because it's 7 plus negative 17 over 8 and 7 minus negative 17 over 8. That gives me my two solutions. They're not pretty, and I'm not actually going to solve it out, but I wanted to give you this equation. If you're wondering if you need to know this equation, my answer to you is almost certainly yes. And I say almost for this reason. If you're very, very adept at the calculator, if you can use the calculator very, very well, you may be able to avoid the worst of this. But my advice to you is to learn it. Learn this equation. Let's try out some quadratics questions. Pause the video and give these a shot. All right, so let's run through these questions here the algebraic way. And after we do that, I will show you how to solve these very, very quickly on the calculator, but we'll work out the algebra muscles a little first. Let's start with this first one here. What is the solution to the equation below? Well, I hope that looking at this, you recognize that we're dealing with a quadratic. How do I know that? The x squared term. So I have an x squared term and an x term and some constants there. And so that screams to me, this is a quadratic. Well, let me combine like terms and get everything on one side. 2x squared, subtract 28x from both sides, minus 28x. Add 17 to both sides, plus 98 equals 0. Okay, now to make my life a little bit easier, let me divide everything by 2. You see what I'm doing that? Right? All of these terms are even. I'll divide the left side by 2, and I'll divide the right side by 2 because the right side is 0. And if I divide 0 by 2, I get 0. So what I get is x squared minus 14x plus 49 equals 0. All right. And if I'm factoring, I'm doing my factor trick, I'm looking for two numbers that when you multiply them together, multiply to positive 49 and add to negative 14. Now, you may see the answer right away, but if you want to run through it, you might say, okay, well, there at least one of these has to be a negative number, right? Because I end up with a negative 14. So one of them has to be negative. But the product, the third term, ends up being positive. So two negative numbers. Well, negative 49 times negative 1, no, does not add to negative 14. But negative 7 times negative 7 certainly does, right? And I get x minus 7 times x minus 7 equals 0. So in order for this to work, the only way for it to work, x would have to equal 7. Okay, that's all well and good. Again, I'll show you how to do this very much quicker on the calculator, but I wanted to run through that first. Let's try this one out. A rectangular business card, okay, let's draw that out right now. Boom. Here's my rectangular business card. Has a length that is 1.5 inches shorter than its width. If the area of the business card is 10 square inches, what is the width? And we have these answer options right here. Now, before we do the algebra, I just want to point out that this is an opportunity to use one of our emergency parachute strategies. Remember, look at these answer options. They're just sitting out there on the table for us. And we could, if we really wanted to, assume each one of these is a particular width. So let's say the width is 1.5 inches. Okay, well, if the width's 1.5 inches, then the length is 1.5 inches shorter than that, or 2.5. So 1.5 shorter than that, that would be 1. That would be an area of 1 times 2.5, not 10, right? So that one doesn't work. And I would just go down the list. Honestly, I think that's probably the quickest way to solve this without a calculator. But let's set this up as a quadratic since we're going down this path. The business card has a width and a length, right? And I'm told that the length is 1.5 inches shorter than the width. So let me just rewrite this as the width minus 1.5, right? Got the width and then the width minus 1.5. And I know that the area of the card, that is this times that, has to be have 10 square inches. So let me write out that equation. W times W minus 1.5 equals 10. Okay, I'll distribute this in. W times W, excuse me. So that's W squared minus 1.5W equals 10. Subtract 10. What do I get? W squared minus 1.5W minus 10 equals 0. There we go. That's a quadratic. Unfortunately, it's not nice, neat numbers like we had over here, right? I'm dealing with decimals, right? Now, again, you could go to the answer options at this point and say which one of these works out. You could literally just plug each one of these in and that would work. But let's do it the long way since we're kind of committed to it. We have to use the quadratic formula, right? Negative b, I'll write it back out here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's get to it. Our b in this case is negative 1.5. So negative b is positive 1.5 plus or minus the square root of positive 1.5 or negative 1.5 squared, so 2.25, minus 4 times a, 1, times c, negative 10, there we go, all over 2 times 1, or 2a. All right, 1.5, plus or minus the square root of, what was this? 2.25 plus 40, so that's 42.5 all over 2. Almost there. 1.5 plus the square root of 42.5. If you use your calculator, you'll see that this is 6.5. So 1.5 plus 6.5 over 2. That's 8 over 2. So that's 8 over 2. So that's 4. And then 1.5 minus 6.5 gives me a negative number. Well, that's not possible. I can't have a negative distance. So the answer that solves this, or the number that solves this, I should say, is 4. Now, let's take a look at how to solve both of these with a calculator. All right, let's take a look at these two questions again, but this time we'll use the calculator. So we'll start with the first one that we had, which was 2x squared, what was it, plus 81 equals 28x minus 17. Now, the way to see where the solution is where it crosses the x-axis, and that's 7, right? So that's the answer to the first one. Now let's look at the second one, and we can use the equation that we set up for the width and the length. We'll use x for our purposes here, right? Because that's what the calculator recognizes. So the width times the width minus 1.5 is equal to 10. All right, well, we have one solution at negative 2.5. That's not possible. And one solution at 4. That's the answer.